Okay, we are just discussing about name reactions, and already we have studied some of the name reactions in detail. First one is the Stoff condensation, second is the Opner oxidation, third one is the MPV reduction, and fourth one is the Reformatsky reaction. आणि यामध्ये असणाऱ्या ज्या फर्स्ट थ्री रिॲक्शन्स आहेत यावरचे प्रॉब्लेम सुद्धा आपण डिस्कस केलेले आहेत. नाउ लेट अस सी नेक्स्ट. यामध्ये पुढची रिॲक्शन आपण स्टडी करतो आहोत. अँड नेक्स्ट रिॲक्शन इज नथिंग बट द यामध्ये असणारी अगेन व्हेरी इम्पॉर्टंट रिॲक्शन Wagner-Meerwein rearrangement. Okay, it is example of rearrangement reaction, and that particular reaction was discovered by, it is introduced by scientist Wagner and Meerwein. Hence, the name is a Wagner-Meerwein rearrangement. Now, first I will explain a very simple example of this particular reaction, and then we will see actually what is meant by Wagner-Meerwein rearrangement. Okay, let us see simple example. Okay, this is an organic compound. CH3, CCH3, CH3, CH2, Br. Simple example of alkyl halide. Now, what is the name of this alkyl halide? Yeah, alkyl halide चं काय नाव आहे? Yes, it is neopentyl bromide. Now, neopentyl bromide, suppose heated with alkali. It is heated with NaOH or KOH. Commonly, we can write OH minus. This is the symbol for alkali. It may be NaOH or KOH. Now, what should be the reaction? Suppose any alkyl halide, when it reacted with the alkali, what should be the reaction? Here, that bromine should be replaced by OH group. When that alkyl halide is treated with any alkali, then that bromine should be replaced by OH. And this is nucleophilic substitution. Suppose that compound undergo unimolecular SN1 reaction, unimolecular nucleophilic substitution reaction. Now, what is the expected product? That bromine should be replaced by OH, and we should be get neopentyl alcohol. This is our expected product. When any alkyl halide is treated with the alkali, then that halogen should be replaced by OH group. In the same case, या सुद्धा केस मध्ये काय होत आहे? Neopentyl bromide on reaction with alkali, here that compound having halogen means that halogen, that bromine should be replaced by OH group, and we should be get neopentyl alcohol. This is our expectation. But in actual practice, we do not get neopentyl alcohol. यामध्ये आपण हा प्रॉडक्ट आपल्याला मिळत नाहीये. There is no formation of neopentyl alcohol. In actual practice, there is a formation of some different product. We get this type of the compound, and this is nothing but the 2-methyl-2-butanol. Actually, there are 4 carbon atoms in the chain, hence it is butanol. Then there is a methyl group. Also, OH group is present on carbon atom number 2. Therefore, it is 2-methyl-2-butanol. Okay, we get unexpected product. Question arises: why there is a formation of 2-methyl-2-butanol? Why we do not get that neopentyl alcohol? आपल्याला neopentyl alcohol का मिळत नाहीये आणि हा 2-methyl-2-butanol हा अनएक्सपेक्टेड प्रॉडक्ट कसा मिळतो हे आपण बघणार आहे. लेट अस सी मेकॅनिझम ऑफ दिस रिएक्शन. ऍक्च्युअली मेकॅनिझम आपण बघूया, देन वी विल गो टुवर्ड्स इंट्रोडक्शन ऑफ Wagner-Meerwein rearrangement. Okay, I will explain the mechanism. Now let us see mechanism, and from the mechanism we can conclude or we can predict the formation of 2-methyl-2-butanol. Okay, we know that this is SN1 reaction. This is SN1 reaction. Our starting material is a neopentyl bromide. Now, what is the mechanism for SN1 reaction? In the first step, a bond between that carbon and bromine, it undergo breaking. Actually, this bond between carbon and bromine, this bond undergo breaking. Electron pair goes towards bromine. It acquires negative charge. Suppose there is a loss of Br minus. Okay, this is the byproduct. I will write on the arrow. म्हणून मी त्याला negative sign दिलेला आहे. There is a loss of Br minus. Now, what should be the charge on the carbon? Okay, this is the covalent bond between carbon and bromine. During this bond breaking, electron pair goes towards bromine. It acquires negative charge, and carbon acquires positive charge, and thus there is a formation of positively charged carbon, and this is the nothing but the intermediate, and that intermediate having positive charge on the carbon, therefore it is called carbocation. Suppose that intermediate is called carbocation first. Okay, this is the first step, formation of carbocation. This is the unimolecular SN1 reaction. Okay, and it involves just formation of carbocation in the first step. Now, this carbocation is a primary in nature. Therefore, that carbocation undergo specific type of rearrangement. आता इथं मात्र बघा, this carbocation is quite unstable. Therefore, it undergo a specific type of rearrangement. Here, this methyl group shifted on positively charged carbon. म्हणजे इथला मिथिल ग्रुप या पॉझिटिव्हली चार्ज कार्बन कडे शिफ्ट होतो. पॉझिटिव्हली चार्ज कार्बन मीन्स इट इज इलेक्ट्रॉन डेफिशियंट कार्बन. देअरफॉर दॅट मिथिल ग्रुप गोज टुवर्ड्स दॅट पॉझिटिव्हली चार्ज कार्बन. आणि इथला जो कार्बन आहे सेंट्रलचा, त्या सेंट्रल कार्बन नाउ एक्वायर पॉझिटिव्ह चार्ज अँड दिस इज कॉल्ड 1,2 शिफ्ट ऑफ मिथिल ग्रुप. हियर 1,2 शिफ्ट ऑफ मिथिल ग्रुप टेक्स प्लेस. मिथिल ग्रुप मायग्रेट्स फ्रॉम दिस सेंट्रल कार्बन to the electron deficient carbon to the positively charged carbon. इकडे movement होते and we get another. Now that central carbon acquires positive charge. आणि हा जो मिथिल ग्रुप आहे, हा नवीन मिथिल ग्रुप इथून इकडे शिफ्ट होतोय. मी याला थोडं सर्कल करतो म्हणजे लक्षात येईल. ओके, दिस इज अवर मिथिल ग्रुप. नाउ इट इज शिफ्टेड टू दॅट टर्मिनल कार्बन. तो इकडे शिफ्ट झालेला आहे and therefore that central carbon now acquire positive charge and we get the another intermediate in which also carbon having positive charge. Therefore, suppose this is the intermediate carbocation second. This is the carbocation first and this one is the carbocation second. Okay, now why that shifting of methyl group takes place? Because that carbocation second is a tertiary in nature, while carbocation first it is primary in nature. And we are very well known about the stability of carbocation. Always tertiary carbocation is more stable than secondary, which is more stable than primary. Means here that tertiary carbocation is more stable. Hence, primary carbocation easily undergo migration, easily undergo shifting of methyl group to form more stable tertiary carbocation second. Okay, this is the 1,2 shift of the methyl group. And actually, why that reaction is called rearrangement? Because rearrangement occurs, migration of group occurs here in this particular second step, and therefore that reaction is called rearrangement reaction. Now let us see the next step. Now in the next step, our nucleophile, our OH minus, we are using alkali, means there is a nucleophile. Now this nucleophile attack on the positively charged carbon and here it form a bond with that carbon आणि मग तो कार्बन बरोबर बॉन्ड तयार करतो and there is the formation of bond between carbon and OH. And thus we get the 2-methyl 2-butanol as a final product. म्हणजे हा OH मायनस इथे अटॅक करत नाहीये, या OH मायनसचा अटॅक इथं होत नाहीये. का होत नाहीये? तर हा अनस्टेबल असतो, तो स्टेबल नाहीये कार्बोकॅटायन हा, आणि इझिली कन्वर्ट होतो कार्बोकॅटायन सेकंड मध्ये. अँड देअरफॉर हियर दॅट न्यूक्लियोफाइल अटॅक ऑन द कार्बोकॅटायन सेकंड here central carbon and there is the formation of bond between that carbon and OH and we get the 2-methyl 2-butanol as an unexpected product. Okay, this is just about the mechanism of this reaction. या रिएक्शनचा मेकॅनिझम आपण एक्सप्लेन केलेला आहे आणि यामध्ये आपण काय एक्सप्लेन करतोय, हाऊ देयर इज द फॉर्मेशन ऑफ अनएक्सपेक्टेड प्रोडक्ट, हाऊ देयर इज द फॉर्मेशन ऑफ 2-methyl 2-butanol, why there is no formation of neopentyl alcohol, हे आपण मेकॅनिझम मध्ये एक्सप्लेन केलं. अँड सच टाइप ऑफ रिएक्शन्स आर कॉल्ड Wagner-Meerwein rearrangement. Such type of reactions are called Wagner-Meerwein rearrangement. म्हणजे यामध्ये ऍक्च्युअली काय होतं या रिएक्शन मध्ये? These reactions involve rearrangement of intermediate carbocation. यामध्ये इंटरमिडिएट कार्बोकॅटायन जो आहे, दिस इंटरमिडिएट कार्बोकॅटायन अंडरगो रिअरेंजमेंट, यामध्ये शिफ्टिंग होते, यामध्ये रिअरेंजमेंट होते. अँड सच टाइप ऑफ रिएक्शन इज कॉल्ड Wagner-Meerwein rearrangement. त्याला डिफाईन कसं करता येईल बघा. द रिएक्शन which involve rearrangement of intermediate carbocation. The reaction which involve rearrangement of intermediate carbocation is called as Wagner-Meerwein rearrangement. त्याला आपण Wagner-Meerwein rearrangement असं म्हणतोय. This is the example of Wagner-Meerwein rearrangement. Okay, let us see one more example. यामध्ये आणखीन एक एक्झाम्पल आपण बघूया. Okay, tell me the name of compound. What is the name of compound? Yes, it is example of alcohol. CH3, C, again CH3, CH3, CH2, OH. How many carbons? Total 5 carbons are there. This is neopentyl alcohol. Okay, this is the starting material, neopentyl alcohol. Suppose that neopentyl alcohol is heated with the concentrated H2SO4. What should be the reaction? What should be the reaction, expected reaction? Yes, that compound undergo dehydration. Suppose any alcohol is heated with concentrated H2SO4, it should be easily undergo dehydration. Means there is a loss of water molecule. OH from one carbon, hydrogen from adjacent carbon is removed as a water molecule, and that alcohol converts into corresponding alkene. It converts into corresponding alkene. And this is the general reaction. Any alcohol when heated with concentrated H2SO4. Now, what's about this particular compound? Here also it is example of alcohol, and here when it is heated with concentrated H2SO4, there should be loss of water molecule, there should be dehydration, means OH from one carbon and hydrogen from the adjacent carbon. Now here this is the adjacent carbon, but this carbon do not having hydrogen atom. This carbon do not having hydrogen atom. Therefore, what is our expectation? मग आपलं इथे expectation काय आहे? There is no hydrogen at adjacent position. There is no hydrogen on neighboring carbon. Hence, our expectation is that this neopentyl alcohol do not undergo dehydration. I will repeat again. When neopentyl alcohol is heated with concentrated H2SO4, okay, this molecule do not having hydrogen atom at adjacent carbon. Therefore, our expectation is that this molecule should not undergo dehydration. That's a dehydration व्हायला नको आहे. Okay, but in actual practice, this neopentyl alcohol undergo dehydration, and we get mixture of two product. आणि आपल्याला दोन प्रॉडक्टचं मिक्सचर मिळतं. दिस इज द फर्स्ट प्रॉडक्ट CH3 double bond CH3 after dehydration, and second one is the CH2 double bond CH3 CH2CH3. Okay, we get mixture of these two products. Now what is the name of first one? 1, 2, 3 and 4 carbons are there, means butene, right? Then number the carbon atoms कोणत्या बाजूने देऊया? इकडून number 1, 2, 3 and 4. Okay, this is here double bond is present in between 2 and 3, therefore it is 2-butene. Then methyl group is present on the carbon atom number 2, therefore it is 2-methyl-2-butene. Okay, this is the 2-methyl-2-butene. What's about the second? यामधला second product चं काय नाव असेल? It is 2-methyl-1-butene. It is 2-methyl-1-butene. Okay, thus in this reaction we get mixture of two products. We get mixture of two unexpected products. Now question arises, why that neopentyl, how that neopentyl undergo dehydration? Actually, it do not having hydrogen at adjacent carbon, even though it undergo dehydration, and we get mixture of these two products. Now let us see mechanism of this reaction. इथलाही मेकॅनिझम आपण बघूया आणि मग आपण डिस्कस करणार आहोत how actually that neopentyl alcohol undergo dehydration and what is the mechanism. Okay, let us see here also mechanism. Okay, this is our starting material, our neopentyl alcohol. Okay, now in first step we are using concentrated H2SO4, means there is acidic condition. Therefore in first step what happens? This OH group undergo protonation. That oxygen having a lone pair of electron. This is the lone pair of electron. Now this lone pair of electron form a bond with that proton. It form a bond with that hydrogen. Okay, and this OH group undergo protonation. त्याला हायड्रोजनची ऍडिशन होते, प्रोटॉनची ऍडिशन होते, and we get the protonated alcohol. Okay, this is the protonated alcohol actually. Here it having one hydrogen, आणखीन एका हायड्रोजनची ऍडिशन होते. While during that addition, electron pair is completely donated by oxygen. That oxygen form a bond with hydrogen. During that bond formation, electron pair is completely donated by oxygen. Hence, it acquire positive charge. Actually, there is a positive charge on the oxygen, and this is the protonated alcohol. Okay, this is the protonated alcohol. First step for the dehydration. Now, let us see second step. In the second step, what happens? The bond between carbon and oxygen it undergo breaking and there is a loss of H2O. याच्यामधून H2O वॉटर मॉलिक्यूल बाहेर पडतोय. I will mention minus H2O on the arrow. म्हणजे कार्बन आणि ऑक्सिजनच्या मधला बॉन्ड ब्रेक होतोय. There is a loss of water molecule. Now what should be the charge on carbon? Here carbon should be acquire positive charge. It should be acquire positive charge because during this bond breaking electron pair goes away from this carbon. या कार्बन पासून इलेक्ट्रॉन पेअर ही दूर गेलेली आहे. Hence that carbon now acquire positive charge. Okay, this is the positive charge on the carbon actually, and we get the intermediate, and this is the intermediate carbocation because there is a positive charge on the carbocation. Okay, now what is the next step? पुढची स्टेप काय आहे मेकॅनिझम मध्ये? तर ऍडजस्टंट कार्बनवरचा हायड्रोजन बाहेर पडायला हवा. But here adjacent carbon do not having any hydrogen atom. Therefore, what happens here? This intermediate carbocation undergoes shifting of methyl group. It undergo rearrangement reaction. Here also it is primary carbocation. This is primary carbocation. Therefore, it is quite unstable. Hence, what happens? This methyl group migrate from one carbon to another carbon. That's a 1-2 shift होतं, just like previous reaction, and this group migrates towards that terminal carbon, towards that positively charged carbon. म्हणजे methyl group migrate from one carbon to another carbon, and now here this central carbon acquire positive charge. इथं positive charge येतो. Here central carbon having positive charge. Okay, this is migrated methyl group. This is I will circle it. Okay, this is our migrated methyl group, and we get the another intermediate, and this is nothing but the carbocation second, and thus one carbocation converts into another carbocation. Okay, unstable primary carbocation undergo rearrangement. There is a shifting of methyl group takes place, and we get the stable carbocation. Okay, this is the third step. यामधली third step असेल. Now this carbocation, that stable carbocation, may be undergo loss of H plus ion. मग याच्यामधून ऍडजस्टंट आता पॉझिटिव्ह चार्ज कुठं आहे तर या सेंट्रल कार्बन कडे. पॉझिटिव्ह चार्ज कुठं आहे तर सेंट्रल कार्बन कडे. नाव इट लुजेस प्रोटॉन. आता याच्यामधून प्रोटॉन बाहेर पडतो. म्हणजे हा सेंट्रल कार्बनवर पॉझिटिव्ह चार्ज आहे. प्रोटॉन कुठून बाहेर पडेल? इट मे बी लूज फ्रॉम ऍडजस्टंट कार्बन. मग ऍडजस्टंट म्हणजे कोणता? तर एकतर हा असेल, बरोबर, किंवा हा टर्मिनल असेल. दोन्हीपैकी कुठूनही. तर आता सपोज या CH2 मधला एक हायड्रोजन बाहेर पडला तर या दोन्हीच्या मध्ये डबल बॉन्ड येतो, अँड वी गेट सच कंपाऊंड. वी गेट 2-methyl 2-butene. किंवा सपोज या टर्मिनल कार्बनवरचा इथून CH3 मधला जर हायड्रोजन बाहेर पडला तर या ठिकाणी या दोन कार्बनच्या मध्ये डबल बॉन्ड येईल. डबल बॉन्ड appears in between that two carbon, and we get the 2-methyl 1-butene. This is 2-methyl 2-butene, and this one is the 2-methyl 1-butene, and thus intermediate carbocation undergo specific type of rearrangement. There is a shifting of methyl group takes place from one carbon to another carbon, and we get the stable carbocation. Now stable carbocation further loses proton from adjacent carbon, and there is a formation of 2-methyl 2-butene and 2-methyl 1-butene. This is the mechanism of this particular reaction. Here also that reaction involve rearrangement of intermediate carbocation. Hence it is example of Wagner-Meerwein rearrangement. Each and every chemical reaction, कोणती reaction असो, those reactions which involve rearrangement of intermediate carbocation, if there is a shifting of group takes place from one position to another position in the same carbocation, then that reactions are called Wagner-Meerwein rearrangement. Okay, this is a very interesting reaction from the organic chemistry and having wide application in synthetic organic chemistry. Now let us see next one. यामधलं आणखीन एखादं application आपण बघणार आहोत. Now let us see next reaction. Okay, again there is example of alkyl halide. Okay, this alkyl halide also same type of reaction. म्हणजे सुरुवातीचं पहिलंच एक्झाम्पल आपण पाहिलं होतं. Neopentyl bromide, similar to that. Instead of methyl group, I will take phenyl groups here. C6H5 is the phenyl group, means aromatic ring is there, benzene ring is there. Instead of writing complete ring, we can write C6H5, किंवा आपण pH असे मेन्शन करू शकतो. Simply pH, it indicates there is a phenyl group. Okay, there are 3 phenyl groups at attached to that carbon, then CH2Br. Okay, this is the simple example of alkyl halide. Suppose when in first step, what happens? It is when treated with the alkali. When it is treated with the alkali, undergo SN1 reaction. There is a nucleophilic substitution reaction. In first step, bond between carbon and bromine undergo breaking. Electron pair goes towards bromine. It acquires negative charge. There is a loss of Br minus. I have written minus Br minus on the arrow. Now that carbon acquires positive charge, and there is a formation of positively charged carbon species. This is nothing but the carbocation intermediate. Okay, this is intermediate first for carbocation first. Now it undergoes shifting of phenyl group. Here this phenyl group shifts from one carbon to another carbon, and okay, this is 1,2 shift of the methyl group. Okay, not methyl actually, sorry. Okay, this is the phenyl group. There is a shifting of 1,2 shift of phenyl group from one carbon to another carbon. Okay, this is the shifted phenyl group. Now that central carbon acquires positive charge, and there is a formation of tertiary carbocation, stable carbocation, and now that stable carbocation further react with the nucleophile. Nucleophile attack on the tertiary carbocation. Here that OH minus directly form a bond with that positively charged carbon, and we get the corresponding alcohol. Okay, this is the alcohol, and that reaction is also example of Wagner-Meerwein rearrangement. But here, instead of methyl group, there is a migration of phenyl group. Means aromatic ring can be also migrated. And keep in mind, एक यामध्ये स्टेटमेंट लक्षात ठेवा, as compared to alkyl group, aryl group migrates easily. Aryl group migrates easily than the methyl group, than the alkyl group. Okay, this is the example of migration of aryl group from one position to another position, and this is the Wagner-Meerwein rearrangement. Okay, now let us see some more applications. याचे आणखीन काही applications आपण बघणार आहोत. Let us see next application. Very interesting actually. Okay, now this is the example of cyclic compound. Okay, what should be the name of compound? This is iodocyclohexane. This is the iodocyclohexane. When this iodocyclohexane is created with AgNO2, what should be the expected product? What should be the expected product? Here iodine should be replaced by NO2 group, and we should be get nitrocyclohexane. Okay, this is the expected product. But along with that expected product, we get one more compound. We get one more product for the same reaction. Okay, this is the 5-member cycle. Then there is a CH2NO2. Now question arises, how there is the formation of this unexpected product? Unexpected product या ठिकाणी कसा तयार होतो हे थोडंसं आपण बघणार आहोत. Okay, this is the iodocyclohexane on reaction with AgNO2. Simple, it is substitution reaction, nucleophilic substitution. Therefore, iodine should be replaced by NO2 group. But along with that nitro compound, along with that nitrocyclohexane, या पहिल्या compound बरोबर we get one more compound, 5-member cycle CH2NO2. And now question arises, how there is a formation of this unexpected compound? Let us see again mechanism of this reaction. या reaction चा mechanism आपण बघूया. Yes, this is our starting material. It is nucleophilic substitution. Therefore, in first step, bond between carbon and iodine undergo breaking. Electron pair goes towards iodine, and there is a loss of I minus. यामधून I minus बाहेर पडतोय. Now that carbon, that ring carbon, it acquire positive charge, and we get the carbocation. Okay, this is the positive charge on the carbon, and there is a formation of carbocation intermediate. This is the carbocation intermediate. Okay, now our NO2 minus, इथं जे NO2 minus आहे, simply that NO2 minus suppose attack on the positively charged carbon, then there is the formation of this compound. There is formation of nitrocyclohexane. Directly यावरती जर अटॅक केला तर हा कंपाऊंड तयार होईल. पण आपण बघणार आहोत how there is the formation of 5-member cycle. आता इथं काय होतं बघा, in first step, bond between carbon and iodine undergo breaking. There is a loss of iodine in the form of I minus. Now that carbon acquires positive charge, या कार्बन वरती पॉझिटिव्ह चार्ज आलेला आहे, कार्बन ऑफ सायकल हॅव्हिंग पॉझिटिव्ह चार्ज. Now this carbocation undergo specific type of rearrangement. It undergo rearrangement. Let us see how the rearrangement occurs. Here this bond, यामध्ये असणारा हा जो बॉन्ड आहे, या बॉन्डचं ब्रेकिंग होतं, and there is a formation of new bond between this carbon. मी थोडंसं याला मार्क करतो म्हणजे लक्षात येईल तुमच्या. या ठिकाणी हा कार्बन आणि इथला पॉझिटिव्हली चार्ज कार्बन, या दोन्हीच्या मध्ये नवीन बॉन्डचं फॉर्मेशन होतं. आणि आता पॉझिटिव्ह चार्ज कुठे येईल तर मी थोडंसं याला वेगळं मार्क करतो, स्टार मार्क दाखवतो. दिस कार्बन नाव ऍक्वायर्स पॉझिटिव्ह चार्ज, यावरती पॉझिटिव्ह चार्ज देतो. म्हणजे हा कम्प्लीट बॉन्ड ब्रेक होतो, यामध्ये नवीन बॉन्ड तयार होतो. आता इथं जर नवीन बॉन्ड तयार होत असेल तर सायकल किती मेंबरची होते बघा, 1, त्यानंतर इथं 2, त्यानंतर इथला 3, 4 आणि 5. ओके, आणि हा जो कार्बन आहे स्टार केलेला, इट रिमेन्स आउटसाइड द सायकल, तो सायकलच्या बाहेर राहतो आणि आपल्याला प्रॉडक्ट असा मिळतो बघा, 5 मेंबर सायकल. आणि हा जो स्टार केलेला कार्बन आहे, दिस स्टार्ड कार्बन, इट नाउ एक्वायर्स पॉझिटिव्ह चार्ज अँड दिस one carbocation it converts into another carbocation. This is just a specific type of rearrangement reaction. Okay, now there is the formation of this 5-membered compound having CH2 group outside the cycle, and now that CH2 having positive charge. Okay, now this carbocation further react with the AgNO2, means there is attack of NO2 minus nucleophile. Actually nucleophile attacks on that carbocation, and there is a formation of this unexpected compound CH2NO2. Now there is formation of bond between positively charged carbon and NO2 group, and we get the unexpected 5-membered compound. And this reaction is again example of Wagner-Meerwein rearrangement, because all such reaction which involve rearrangement of intermediate carbocation, they are called Wagner-Meerwein rearrangement. Here also that intermediate carbocation undergo, actually 6-membered intermediate carbocation undergo rearrangement reaction. It converts into another 5-membered carbocation, and thus that 5-membered carbocation, further there is attack of NO2 minus on that 5-membered carbocation. Actually carbocation having positive charge having the CH2 group which is outside the cycle, and there is a formation of that unexpected compound. This is just about the example of Wagner-Meerwein rearrangement. Now let us see next example, next application. Again, this compound is example of primary amine. Okay, here 3-membered ring is there, then CH2, NH2. Name of the compound is the cyclopropyl carbonyl amine. This cyclopropyl carbonyl amine, when treated with the NaNO2 plus HCl followed by hydrolysis, what should be the expected product? This is example of primary amine. Suppose any primary amine, when treated with the NaNO2 plus HCl, when it is treated with the NaNO2 plus HCl, it undergo diazotization. Suppose it is, I will explain a general example. Here are NH2. When it is treated with the NaNO2 plus HCl, it undergo diazotization. Diazotization means NH2 group converts into the N2Cl, that is diazonium chloride. Okay, here there is a formation of diazonium chloride or N2Cl. Okay, now this diazonium chloride further on hydrolysis, that's a hydrolysis झालं, here that N2Cl is replaced by OH group. Means simply we can say that suppose RNH2 primary amine on reaction with NaNO2 HCl followed by hydrolysis, that NH2 group is replaced by OH. That NH2 group is replaced by OH. Here also our cyclopropyl in this example, cyclopropyl carbonyl amine, there is a NH2 group. When it is treated with NaNO2 plus HCl followed by hydrolysis, what is the expected product? Yes, that NH2 group should be replaced by OH, and we should be get cyclopropyl carbinol. We should be get cyclopropyl carbinol. This is the general trend for the diazotization followed by hydrolysis. This is the general trend. But in the particular reaction, we get one more product. And this is the another compound. And this is nothing but a cyclobutanol. Now, in this case, we get unexpected cyclobutanol. Cyclopropyl carbinol, this is the expected product, no doubt about this. But this is unexpected product. Now, we will see in detail in the mechanism how there is a formation of unexpected product, how there is a formation of cyclobutanol, which is unexpected for us. Therefore, we will see the mechanism आपण बघूया how there is formation of cyclobutanol. Okay, this is our starting material. Yes, three-membered cycle, then CH2, NH2, cyclopropyl, carbonylamine. Okay, when it is treated with NaNO2 HCl, yes, first step, that NH2 group converts into disonium chloride. Actually, this is diazotization reaction. That reaction is carried out at low temperature, near about 0 to 5 degrees Celsius. We are carrying out that reaction. Now, it converts into corresponding disonium chloride. Now, this disonium chloride undergo decomposition. Okay, bond between carbon and nitrogen undergo breaking. Yeah, bonds इथून breaking होतं. This electron pair form a triple bond between two nitrogen. इथं triple bond तयार करतो. Here, this bond also undergo breaking. This electron pair goes on the chlorine. म्हणजे there is a loss of N2 gas. इथून nitrogen gas म्हणजे disonium chloride decomposes. There is a loss of nitrogen gas, and I will mention loss of minus N2 is there. Okay. Now, what should be the charge on the carbon? During this bond breaking, during this heterolytic bond breaking, electron pair goes away from the carbon. Hence, this carbon acquire positive charge. Okay, there is a positive charge on the carbon. In first step, that primary amine on a reaction with NaNO2 plus HCl, reaction takes place at low temperature. There is a diazotization. We get disonium chloride. Further undergo decomposition. There is a heterolytic bond breaking, and therefore carbon acquires positive charge, and we get the intermediate carbocation. This is intermediate carbocation. Now this intermediate carbocation undergoes specific type of rearrangement. What happens here? This bond undergo breaking. Yeah, bonds breaking होतं, and there is the formation of new bond between this. I will make red mark to it. Between these two carbon. या दोन कार्बनच्या मध्ये नवीन बॉन्डचं फॉर्मेशन होतं, and we get 4-membered cycle. Total carbons किती आहेत आता? 1, 2, 3, and 4. And there is a formation of 4-membered cycle. Therefore, now that carbon acquire positive charge. या कार्बनवर मात्र काय होतं? I will make star to it. It acquire positive charge. त्यावरती positive charge येतो. Means this bond undergo breaking. Formation of new bond between that two carbon. This carbon, हा carbon आणि positively charged carbon. यामध्ये नवीन बॉन्डचं फॉर्मेशन होतं. While now that star marked carbon acquire positive charge. Okay, this is the 4-membered cycle, and here positive charge is on the cyclic carbon. Okay, this is just about the next intermediate. Now we are carrying out hydrolysis, and therefore nucleophile OH minus directly attacks on the positively charged carbon, and we get the cyclobutanol. And this is the formation of cyclobutanol. We have studied the mechanism of this particular reaction, and here also there is a carbocation. The intermediate carbocation undergo rearrangement. There is a rearrangement of intermediate carbocation, and therefore it is also example of Wagner-Meerwein rearrangement reaction.